A very good day to everyone. Myself Swathi.P from Sri Venkateshwara College of Engineering. So for today's video, the topic is cloud computing. Under that, we have the machine reference model. Let us see what does this machine reference model consists of, its diagrams, and few of the briefly. Let us explain the machine reference model. Okay, so basically, machine reference model. When execution environment is virtualized at unlike levels of stack of computation, um, then it requires a reference model which defines the interfaces within the level of abstractions. So to execute any of the virtualized environment, we need a model which defines the interfaces within the level of abstractions, and this level of abstraction hides the details of implementations. This projects an idea that virtualization techniques can substitute any one layer and can intercept the cells with the calls which are directed to it. That's why a clear separation any one layer can simplify their implementations, which only need an emulation of the interface. So and proper responses with the underlying layer. At the base layer, the model for hardware is declared or manifested on terms of an architecture, that is instruction set architecture. We have two architectures. So the first one is the instruction set architecture. So this is the basic machine reference model. So here we can see the APIs, which are the application program interfaces, and ABI, and ISA is the instruction set architecture. ABI is application binary interface. So applications, libraries, and this is the operating system and hardware. Here you can see the applications that performs on the API calls. They they are like interpreters. API calls, application program interfaces calls, and system calls. Operating system works on the instruction set architecture, and hardware user ISA and user uh, ISA. All these are, this is the basic machine reference model diagram. So let us see briefly each of this. So a machine reference model, virtualizing an execution environment at different levels of computing stack, requires a reference model that defines the interfaces between the levels of abstractions which hide implementation details. So machine reference model virtualizing while in execution environment during different levels, it defines the interfaces between the level of abstraction which hides the implementation details. They do not show how the implementation is done. They just show the abstraction, that is the raw. That is the basic outside environment of the models. So from this perspective, virtualization techniques actually replace one of the layers and intercept the calls that are directed towards it. Modern computing systems can be expressed in terms of reference model described in the figure. Above figure, we saw the applications, operating system, and hardware. In that figure, we saw the system calls and API calls separately for each of the systems. So at the bottom layer, the model for the hardware is expressed in terms of instruction set architecture. That is the bottom layer, the model for hardware. And the least one, that is the bottom layer, bottom was the hardware, that is expressed in terms of the instruction set architecture, which defines the instruction set for the processor, register memory, and interrupt management. So ISA basically consists of the instructions for processor, registers, memory, and interrupts management. So instruction set architecture is the interface between hardware and software, and it is important to operating system developer and developers of the application that directly manage the underlying hardware users. The application, next one is the application binary interface. This main aim of application binary interface was to separate the operating system layer from the applications and the library, which are managed by the operating system. ABI covers details such as low-level data types, alignment, and call conventions, and defines a format for executable programs. Calls are defined at this layer. We had seen in the previous diagram the system calls, that is system calls and API calls with it. So ABI has call conventions and defines format for executable programs. The interfaces allows portability of application libraries across operating systems that implement the same application binary interface. The highest level of abstraction is represented by the application programming interface, which interfaces application to libraries or the other underlying operating system. So here you can see the instruction set architecture. We have few of the properties, that is, it acts as an abstraction and hides all the good implementations of the model. So defines the instruction set for the processor, register, memory, and interrupt management. It is an interface between software and hardware, and it is a mandatory for operating system developers of application who directly manages the core hardware. The operating system layer is separated by the application binary interface from the application and libraries, which are managed by the operating system. So here you can see the diagram. Here, instruction set acts as it separates the software from hardware. So few of the good properties of instruction set architecture. It lasts through many generations. That is, the portability is very good and used in many different ways. Like generality, provides convenient functionality to higher levels, permits an efficient implementation at lower levels. So instruction set architecture basically consists of the processor register. It provides instruction set for processor registers and memory and interrupt management. The main aim of the instruction set architecture, it separates software from hardware. So let us see the next one, that is application binary interface. It covers the facts such as low-level data types and call conventions, and it also defines a format for many programs. Many system calls are defined at this level. Moreover, this type of interface enables portability of various applications and libraries across operating system, which employ the same ABI. Application programming interface is represented by the highest level of abstraction. This application programming interface applications to libraries of the core, or an action is to be performed to the application level ABI, and the two which are responsible to make it done. Mainly CPU runs on two privilege levels, that is the user mode and the kernel mode. In this mode, memory access is restricted up to some limit, whereas access to peripherals is denied. Memory access is permitted to some limit. The limit is set only to which only the access is done for user mode, and for the kernel mode, CPU instructions which manages a memory and how to be accessed, and it also has the instruction which enable access of the peripherals like this network cards from one running program to another running program. CPU switches automatically. The expansions and applications of computing system are simplified by this layered approach. Application of multitasking and coexistence of multiple executing is simplified by this layered approach. So the next one is the instruction set exposed by the hardware has been divided into different security classes that define who can operate with them. The first distinction can be made between privileged and non-privileged. Non-privileged instructions are those instructions that can be used without interfering with other tasks because they do not access shared resources. This category contains, for example, all the fixed points and arithmetic instructions. Privileged instructions are those instructions that are executed under specific restrictions. There are no restrictions in non-privileged, but here few restrictions are there and are mostly used for sensitive operations which expose behavior sensitive or modify the privileged state. For instance, behavior sensitive instructions are those that operate on the input or output, whereas control sensitive instructions alter the state of the CPU register. So let us see here a possible implementation feature. Here we have a security and machine restriction model, that is the here we can see the ring 1, ring 0, 1, 2, 3, it goes on, and the least privilege mode is ring 3. Privilege the 2 and 1 are the privilege mode, and most privileged mode is the ring 0. In the ring based, ring 0 is most privileged and ring 3 is the least privileged. Ring 0 is used by the kernel of the OS, ring 1 and 2 are used by the OS level services, and ring 3 is used by the user. Recent systems support only two levels, that is the ring 0 for supervisor mode and ring 3 for user mode. All the current systems support at least two different execution modes, supervisor mode and user mode. The first mode denotes an execution mode in which all the instructions can be executed without any restrictions. This mode, also called master mode or kernel mode, is generally used by the operating system to perform sensitive operations on hardware level resources. So ring 0 is used for is the most privileged mode, and ring 3 is the least privileged mode. Ring 0 is used for the OS, and ring 3 is used for the OS services. So thank you. So for today's video, we saw the cloud computing machine model. In machine model, we have the two architecture: instruction set architecture, and one more is the ABI, that is application binary interfaces. We have seen within the instruction set, there are most instruction sets are given for the memory registers and memory registers and binary sets. Also in ABI, we have API calls. So thank you. Have a nice day.